Hi everybody and welcome to an assignment video, this time CS202 assignment 1, the Unigram and Bigram extractor 2.0. And so this assignment is actually a modification of an old assignment that I came up with a couple of years ago, and the students really liked it. Some of them didn't, but a lot of them did. And I actually liked it so much that I kind of expanded this idea into a research paper. And I'll talk about that in a minute, but I had a lot of fun, not just making the assignment, but just kind of trying to take it to the next level with the paper that I did. And so I thought, why not bring it back with a twist and see how you all do with it. And it's a great assignment because it's not particularly hard, but it does require some critical thinking to do things the easy way versus the hard way. And I think that's a very important thing to always have when you're coding. It's not just about whether the actual code is difficult, but whether you're thinking through before coding and, having a plan rather than just starting to write code. And so what is this assignment? Well, to be able to tell you what this assignment is, well, first of all, I recommend that if you haven't already, take a look at the PDF, and then I will try to sort of enhance the information there. And so let's first talk about what a bigram and a unigram are, in case that you're not familiar with that. So I'm going to go ahead here and write a sentence. I'm going to say, I like to eat. Okay? And so this sentence is made up of 4 words. In fact, let's just get rid of the dot just for a minute here. Okay? So we got 4 words. And so each of these words, I would consider this to be unigrams. They're single words. However, in this sentence, there's more than just unigrams, there's bigrams. So for example, bigrams are going to be 2 pairs of words or tokens. We also use that interchangeably for words that are found in the text. So for example, that's a bigram and that's a bigram. However, there are other bigrams in this text. Technically speaking, that's a bigram as well. There's nothing here, so I would say this is quite a bigram because there's nothing in front, but unless you consider the emptiness to be something. But for now, let's not put that in. Similarly, at the end, this is not a bigram because there's nothing afterwards. So there's technically 3 bigrams in this text. And if I happen to add more to this, so let's say the sentence is, I like to eat cookies. I hope that's how you spell cookies. Then now there's 5 unigrams, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then there's going to be 1, 2, and then technically 3 and 4 bigrams. Okay? And one easy trick to find out how many bigrams there should be is going to be the number of words minus 1, as long as you have at least 3 words. And if you have only 2 words, then you're only going to have 1 bigram. Well, actually, yeah, number of words minus 1. Yeah, that actually works in that case too. So, yeah. Just like that, there is anything more than, just unigrams and bigrams. So we kind of call the general case the ngrams. So for example, if we're talking about 5 grams, that would be 5 word pairs. And so why am I talking about this? Well, it turns out that knowing the unigram, bigram, and whatnot of a text is very useful for natural language processing. So for example, if I ask you what's the importance of the unigrams found in a text, then you can come back and say, well, that's literally your dictionary of words. So if I went ahead and said, where can I find all the unigrams in the English language? You should go back and say, well, in the dictionary. That's literally all the words that appear are going to be there. And because it's useless to have a word, if a word appears 10 times in a piece of text, you don't need to put 10 entries in the dictionary. You can just put 1 entry. And of course, with English, one word can have multiple meanings and whatnot. But what I'm saying is that you only list it once. And so the unigrams are going to be unique. So if I have a sentence like, I am 5 cookies and 5 glasses, blah, 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 then technically speaking, when you're building your ngrams, you don't need to put the word 5 twice. What you can do instead is if you're interested in the frequency of a word existing in the text, you can go ahead and put that there as a number. So, for example, I will have a 1, and so would any other word like and, but 5 would have 2. Now, why is that useful to keep track of? Well, word frequency can be useful so that you can know what words appear the most often, and so you can do further processing on that. So, for example, if you're trying to correct text, right? So I did a lot of research for my PhD in OCR post-processing and error correction. So OCR is when you scan something. So let's say there's a sentence that has the, I am 5. And I go in and I scan this. And in fact, I think that my iPad has the ability to do that, to OCR something. I think convert text, convert selection, and voila. See that? So now it just converted it into actual text that I could type in. So that is known as optical character recognition, and the process of converting that is a very cool process. I don't want to get too deep into that. If you want to see more, you can check out some videos I have on my channel. But ultimately, when you finish that process, there are sometimes mistakes. And those mistakes you want to automatically try to correct, or at least to suggest to someone who can look at this instead of just making them correct it like raw. And so one of the ways that you can try to suggest a correction is you can look at the context. So whenever you're reading a sentence and you're proofreading something and you find a typo in that sentence, what do you do to correct it? Well, one of the things you do is you think about, well, what words exist in the English language? And then you see which one's the closest. We call that the edit distance of a word. And that's one of the ways that you can actually correct the word. You just see, well, if you're writing the word souvenir, but instead of writing an uppercase V, instead of writing like V as in vector, you write B as in Bravo, then, you see that there is, just off of memory, you see that there isn't really that many words that would have, something that looks like this, that's not the word souvenir that's correct. So, that's your similarity between that and other words. That's one way of correcting errors. Another way of correcting errors is to look at context. You look at the words around. That's what they tell you when you're in grade school. You're like, you don't know what a word means? What do? Well, you look at the words around it to see if they give you a hint. That's your context. And that's very, very powerful for correcting things. And so when we have a typo in a sentence, we can use the words around it to be able to find out what that correct word is. And this is very, very good. It works pretty well. Not always, but it works a lot of the times. When wouldn't it work? Well, if like I like to eat cookies, let's say that's misspelled. Well, okay. Context doesn't really help you much because this could be literally anything, like soup, potatoes, apples, bananas. It could be literally anything. So context isn't really going to help you there, unless maybe you go further out and you see that this is about something talking about like pastries. And then you're like, oh, okay, it's a pastry. So maybe that limits it down to not being an apple, but maybe being a cake or a cookie. So in this case, it doesn't help you much when it comes to confirming what the correct word is, but for that you can use the similarity to your Unigrams because you can look at the dictionary, right? So in this case, it's not that useful, but in the case where, for example, it's a more specific sentence, like in your assignment, there's a sentence that says appear twice, so they have a frequency of 2. So you can use the context there of the word twice for the word 2 if it was misspelled or something. Or you can look at sentences that have something like the Las Vegas Strip, and let's say the word Vegas was misspelled. Well, there isn't that many Las something strip other than Vegas. So you can use it based on your bigram or whatever ngram you're using to suggest a correction. In this case, how do you pick between different words that could fit there? Like, what could fit other than Vegas? Well, maybe there's a city somewhere that's called like Las Cookies Strip. Okay, let's just say that's actually a thing somewhere in the world. That's a real combination of words. Well, when you're looking at let's say that's a trigram because that's 3 words. When you look at your trigram, of all of the possible mentions, let's say on the internet or somewhere, then you will see that Last Biggest Strip has maybe like hundreds of thousands of mentions, whereas Last Cookie Strip has 10. So then you can go ahead and look at frequency there and say, okay, well, yes, it could be either or, but based on the frequency of something appearing, we go with the one with the highest probability because that gives us the highest probability of being correct. So why am I talking about all of this? Because while you're not going to do something super fancy like that, you are going to kind of do the heart and soul of this, which is to generate that unigram and bigram. And you could use the same code that you're going to do for this to generate any ngram that you would like, actually. So here's your assignment. And, I talk about how to clean up things because that's also important. You got to clean up text, remove things like punctuation, lowercase everything, etc. So you can read that, and that's all I talked about. You can also take a look at some of the papers that I've written. Just to give you context, I went ahead and said, okay, can I build the unigram and bigram of the entire English Wikipedia? And how fast could I do it, potentially? And so I went ahead and did that. And that's what this paper is about. And spoiler alert, it took a long time. Not as long as you would think, but it took about over a day to do that. And the biggest thing was that I needed about 500 gigabytes of RAM to be able to do that. And that's because I did something really simple. Literally the same stuff you're going to do for the assignment. I read in all the words, I generated these unigram and bigrams, and then I sorted them so I could figure out the frequency and return them sorted, and combine duplicates and things like that. And then that was it. But yeah, that took about 33 hours. So very fun stuff. I welcome you to check this out and read it if you're curious. I don't actually have the code here in C++. I believe I do have some snippets in Python, but that won't really help you much at this level, because again, the concept is not hard. What's tricky is just going to be how to code this, like understanding what to do first and whatnot. So anyways, just wanted to show you that because this is something that this is not the end. You can definitely make this something even better. So let's go ahead and show you an example of the code running of what you should do. So I have my files here. I have the assignment C++ file that this is what you're going to code, and then I have some text file, and this is going to be the Gutenberg time machine. But you could run this on whatever text you want. It's just that this is the one that we're going to be using for the grading. And so, or actually, maybe we'll use a different one, and I won't tell you what it is. But your code should work anyways, so that way you don't hard code the output or something, So okay, so to compile it, you just G++ compile it. You can also do std C++11, whatever it is that you want, but you make sure you state that based on the on your submission, or also whatever works in CodeGrade or what your instructor tells you, depending on the sections you're in. So after you compile it, you're going to have your a.out. So then if you just run it like this, you get an invalid arguments message because you need to actually pass in the file you're going to work with. So let us go ahead and pass in the time machine book. This is literally just the entire book. In fact, let me show you what that looks like. So this is literally just a text file of the entire book. And it's not that long when you just have a text file, actually. I'm like, wow, it looks small. But yeah, and that's from the Gutenberg, so that's copyright free. I'm not doing any copyright violation by sending it to you. But anyways, when you execute it, in this case, because we haven't talked about dynamically allocated arrays, which is something that we want to revisit in this assignment I will in my section, but maybe your other instructors won't. But I would welcome you to revisit this assignment when you learn about dynamic allocation, just to see how much nicer it is to do that way. However, because you don't know that, I went ahead and did a fixed size array. Be forewarned, making an array of size 50,000 is not something that the computer always likes. Your program may segfault. If it does, try lowering this number until it works. Or if you know how to use a vector, go ahead and make a vector instead of doing a constant size array. Just because it can be finicky about allocating that much memory in C++ thing. So yeah, if your thing crashes, just start out by trying to allocate that array. If it crashes, then plan B, try to use a vector or lower the size. How to use a vector is quite trivial. If you've never done it before and you're 135, go ahead and Google how to create a vector array, and you will find out the syntax for that. And then bam, you're good to go. Like you should be doing it for just about anything you don't know. Google has all the answers. You do whatever you want with Google. You can build a house, build a car, probably build a nuke too, if you really were into that. Okay, so I'm going to turn logging on so you can see what that is like by hitting yes. And then now it's sorting. Because I wanted to see how long it would take with just the simplest form of the sort. I am actually doing bubble sort on the entire book. So as you can see right now, it is working. But I welcome you to use a better sorting algorithm, or you can use an STL to run something from the library, like if you know how to use quicksort or something. Again, something you can Google what the command is for that and what you need to include for it to be able to do that. But even if you do use quicksort, I mean, like it just finished now. So it's long, but it's not that long. It's maybe what, like 30 seconds? I don't know. Watch the on the YouTube link when I started and when I finished, and then you'll find out how long it took on this computer. Okay, so and this is an i9 11th generation, though, to be fair. But yeah, okay. So let's go ahead and hit save because we want to save what the 1 grams and the 2 grams are. So that's one of the commands that we can do. And this is like a little menu, and basically every time that you enter a command, it's going to prompt you back to the menu to keep doing other things. So the save thing will actually save the list, the unigram list and the bigram list. When it comes to the unigram and bigrams, what those do is allow you to search for the frequency of a specific ngram. So for example, if I type in unigram and I enter the word da, what it tells me is that the word da appeared 2,463 times in that book. You might be like, wow, it's a lot. Well, it turns out that it is one of the most common words in the in any piece of text, like the word da. That's why if you're watching Wheel of Fortune and whatnot, you know, they say like the letters, they give you T, N, L, E because they're the most common letters. So, you know, after that, you know, like you're not going to ask for X in the Wheel of Fortune because that's a very rare letter, right? Unless, you know, the word tells you that it's that. So, yeah, a lot of very interesting things with an LP here. Same thing with bigram. We can search for 2 words, but in this case, we enter 1 word at a time. And everything should have been lowercase at this point, so make sure you search for lowercase. Let's look for something like time machine, since that should appear a lot, since it's literally the name of the book. Turns out that it appears 44 times. Okay? Finally, let's go ahead and look at what the index does. So what the index does is it's going to print out whatever word. This is sorted alphabetically by the first word and then the second one. So it's going to go with that. So if I go ahead and type in something like 44 of like the bigram, actually this is a unigram, then it's going to tell me that the word, oh wow, that's interesting. Machine is actually the 44th word there. That's a scary coincidence. Very cool. Let's try that again actually. Index, let's try 43 of the unigram. I'm curious what that is now. Sum. Okay, so, I guess, yeah, that's right. The unigram is sorted by frequency. So the most common word will be at the top, and then the least common will be below. As you can see, this appears 94 times versus 95, which is why that appears there. Let's see what the most common word is then. So if I type in index 0 of the unigram, turns out that the most common word is da. See, I wasn't lying. That's always usually the most common thing. So there we go. Let's see what the most common bigram is. And it puts 2 little quotes. I think that's because of the cleanup. That appeared 3 times. So that's to be expected. But anyways, let's go ahead and see what these files contain. So let's go ahead and quit our program by either typing quit or just Q, and it closes. And let's see what those log files should look like. So as you can see here, we got our frequency of the words. We got da as the most frequent. By the way, don't panic if these numbers are off by 1. I might have a bug on this and I'll have that fixed. So if yours are off by 1 and you're for sure that it's correct, then no fear. But I do think I fixed it this time. This might be off by 1. I can't remember if I fixed that. So yeah, you can see all the frequency of the words. Now I'm curious, what kind of word only appears once? Maybe all the way at the bottom. So we can see that more than half of the words in the book only appear once. That's actually pretty normal if you know OCR and NLP. So we can see the word reasoning only appears once. Dining hall, I wonder if that's a glitch with scanning or if it really was 1 word in the book like that. Maybe that was a single word. Same with lost perhaps. Yeah, something probably iffy with the book with the line feeds. Maybe it's losing that space. But interesting, the word hardest only appeared once in the book. The word telegraph only appeared once. Africa. I'm actually thinking, where do these things appear in the book? I'm curious now, because I was been a while since I read the book. Interpolated. So yeah, that's very interesting. Let's go ahead and look at the 2GMS. So with the 2GMS, oh, that's right. For this one, I sorted it alphabetically. That's why we're not getting the most frequent one. So what I did was, for the bigrams, I am sorting alphabetically, and for the unigram, I am sorting by frequency. And that was to try to do the two different types, basically. So we can see, for example, atmosphere 1. And so why did I sort this alphabetically? Because then you can use it for autocomplete. If you don't know, if somebody enters the word coming, what do you suggest? Well, the most common word that has coming in front of it is going to be the word through, at least according to this amount of text. And so our autocomplete can help us, autocomplete this. But if they go ahead and type in an A as the first letter of this, then they should try to autocomplete with this. So autocomplete is another very good use of this ngram stuff. Finally, let's look at the log, AST1 log. And this is basically going to keep track of all of the things you do to clean up the text. You can read more in the PDF of how this works, but it does things like removing punctuations, removing things that are non-alphanumeric. So for example, it's removing this bracket and this pound symbol, and numbers themselves are then becoming non-alpha. And that's because, like, while it can be useful to have frequency of individual numbers, usually, especially when it comes to error correction and things like that, if you say I am 5 years old, or I am 6 years old, or I am 20 years old, it's good to just combine all of those into I am non-alpha years old, and then you know that's just a number. So it's a very nice thing to do, and I thought I'd throw it in here. So yeah, that's pretty much what most of this cleaning does, is just removing punctuation. And the reason you remove the punctuation is because you don't want this to be its own word and then have the word presentation with like a question mark here be a separate word. You want to combine that. So that's the reason why we're doing this cleanup like this. So yeah, that's pretty much what the log file should do. And then that's pretty much the assignment. So be sure to read the PDF very carefully. Oh, that's not the PDF, that's the paper. This is the PDF. Be sure to read that very carefully. Read all the bullet points. Make sure you thoroughly read this and think about how you're going to approach this assignment before you start coding. I do give you some requirements of things that you should have. I'm not doing that to be mean. I'm actually doing that to kind of help you out as a starting point of what you should do. Like things like what could be useful. Well, it could be useful to have a function that cleans up specifically. So it could be useful to have something that is a sort function, or something that calls your sort function if you have an outsider function. So that's the reason why I'm doing all of these requirements, because I want you to be able to do that. Now, in the past, I said do not use STL, but I'm okay with you using STL, especially if you're having issues with bubble sort being too slow, and you want to be able to run it quickly. So yeah, I have some sample output here, basically what I showed you with other examples. And yeah, please, if you have any questions about this, be sure to ask your TA or your instructor, or you can also send me a message as well on Discord or email, and I'll do my best to clarify anything that pops up. But I thank you for your time. I wish you the best with this assignment, and have a great semester.